All right. Good afternoon, everybody. Today's lecture is Occulomotor Nerve, and that is our third cranial nerve. Previously, I was able to discuss the olfactory nerve as well as the optic nerve. So, oculomotor nerve is the third cranial nerve that takes origin from its own nuclei that are lying within the midbrain. This nuclei of the oculomotor nerve, as previously discussed, they lie anterior to the periaqueductal gray matter of the midbrain. Just behind this oculomotor nucleus, if you can remember, I made mention that there is another nucleus related to this nerve known as Edinger-Westerfeld nucleus, which is lying posterior lateral to the motor nucleus of this oculomotor nerve. So the entire aspect of the oculomotor nerve is motor. There is nothing like sensory portion of it, like other cranial nerves. So the oculomotor nucleus plus the Edinger-Westerfeld nucleus on either side, the axons of these neurons within these two nuclei, they pass out within the tegmentum of the midbrain. And from there, these axons, they bundle together to form the oculomotor nerve. That means the oculomotor nerve contains both fibers from its motor nucleus and fibers from Edinger-Westerfeld nucleus. This oculomotor nerve with these two types of axons, each one of it passes through the red nucleus. And the two nerves, they come out of the midbrain, just by the side of from within the interpeduncular fossa. You can remember that we discussed the fossa that is lying between the two peduncles. So ideally, this drawing, I can just make it like this, so that it looks a little bit much better like this. So something like this. So we can say that these nerves, they pass out of the midbrain through the interpeduncular fossa. If you can remember that these oculomotor nerve nuclei are found at the level of the superior colliculi of the midbrain. I'm sure you can remember that. So these nerves, as they come out from the midbrain through the interpeduncular fossa, they pass forward. So as each of these nerves passes forward, each of these passes through what we call cavernous sinus. That is the sinus within the cranial fossa known as cavernous sinus. And so this oculomotor nerve passes into this cavernous sinus. If you remember that cavernous sinus is just a network of venous sinuses, with the internal carotid artery penetrating into these sinuses. So apart from this internal carotid artery passing into the cavernous sinus, these cranial nerves also pass through. Now we have seen one going into the cavernous sinus. So we'll see other cranial nerves that do pass through the cavernous sinus. So from within the cavernous sinus, before this nerve gets out of the cavernous sinus, each of these two nerves divides into two branches. Okay, so here also the same diagram is supposed to be like that. So we can have this division like this from inside. So we can have the inferior division and the superior division like that. So and then all of these divisions, they now enter into the superior orbital fissure. So now these divisions of the oculomotor nerve into two divisions, upper division and lower division. So the lower division now divides into three divisions. So we have a lower division, which is this one. So the lower division now, as it comes out of the cavernous sinus, it goes, these two divisions, as they come out from the carbonal sinus, upper and the lower divisions, they now continue into the superior orbital fissure. So, as soon as they come out of the superior orbital fissure, the superior division divides into two parts. The first part, the upper branch, supplies one muscle that elevates the eye, what you call levator palpebrae superioris. So that upper division, as I said, it divides into two divisions. One of the divisions supplies the levator palpebrae superioris. The other division supplies the superior rectus. Are you clear? So we have seen that the upper division of the oculomotor nerve supplies the levator palpebrae superioris and the superior rectus. While the lower division, the edengo-ossipal nucleus, the fibers from edengo-ossipal nucleus, they follow the lower divisions together. So they pass into the superior orbital fissure together. And so this lower division, as it comes out of the superior orbital fissure, it divides into three divisions. If you can remember, I said that the upper division divides into two divisions. One supplying the levator palpebrae superioris, the other one supplying the superior rectus. So this inferior division also divides into three divisions. The first division goes into the medial rectus, which is shown here, just lie medial to the optic nerve. And so the other division supplies the inferior rectus, which is just lying below the eyeball. And then the last division of this inferior division is the one supplying the inferior oblique muscle. So we have seen that this lower division divides into three. One supplying the medial rectus, the other one supplying the inferior rectus, the other one, or the last one supplying the inferior oblique. So this nerve, as it follows the inferior division of the oculomotor nerve, it also relates to the inferior oblique division. And so as it follows the inferior oblique branch, it passes upwards to synapse with the neurons within this ciliary ganglion. So there is a small ganglion lying within the orbit known as ciliary ganglion. So this ciliary ganglion is the one here. So the ciliary ganglion is just lying just by the medial side of the optic nerve. And so these fibers from the edengo-ossipal nucleus, they synapse with this ciliary ganglion. And so the post-ganglionic fibers from within the ciliary ganglion, they get out of the ganglion as short ciliary nerves and long ciliary nerves. So the short ciliary nerves, they supply the back of the eye, and the long ciliary nerves, the fibers go forward to supply the iris and the ciliary muscles. So it means that these fibers from the edengo-ossipal nucleus, they control accommodation and the pupillary light reflex. If you can remember, we said that the edengo-ossipal nucleus is responsible for the pupillary light reflex and accommodation. So these fibers from the ciliary ganglion, as they supply the ciliary muscles that control the size of the lens, and the iris that is controlling the size of the pupil itself. So these fibers control accommodation of the eye as well as the pupillary constriction. You understand? So that is, the functions of this. So I'm sure you are all aware about the functions of these extraocular muscles. The levator palpebrae superioris elevates the upper eyelid. Superior rectus elevates the eye upward. It elevates the eye up and also rotates it medially like that, slightly medially. Then the medial rectus also, move the eye towards the medial side, so it rotates the eye towards the medial side. That is adduction. So the inferior rectus, it also depresses, it brings the eye ball down and towards the medial side. And then the inferior oblique, it rotates the eye laterally, and upward, so upward and out. That is the function of the inferior oblique. So much so that by the time you have lesion or trauma at this oculomotor nerve, what is going to happen is that since oculomotor nerve, through its ciliary ganglion, it controls accommodation and pupillary light reflex. So it is responsible for pupillary constriction if the iris contracts. So now, if this nerve is being affected by any means, either trauma or anything like that, that causes, division of that nerve. So there is loss of accommodation. There is also loss of pupillary constriction. So that means the iris will be dilated. So there will be dilatation of the iris as a result of failure of these fibers to constrict the pupil. And so dilatation of the iris, because of this, is what is called mydriasis. It is called what? Mydriasis. Similarly, the functions of these muscles, virtually, that this nerve supplies how many muscles? Levator palpebrae, since it's responsible for elevating the eyelid, now the nerve has been damaged. What happens to the eyelid? There will be no elevation of, so the eyelid will droop. So there's drooping of the eyelid. So there's what? Drooping of the eyelid as a result of paralysis of the nerve supplying the levator palpebrae superiors. Similarly, the other muscles, since they are being paralyzed now because of loss of nerve supply to them, so there will be unopposed function of lateral rectus, because that is supplied by a different nerve, and also unopposed function of the superior oblique, which is supplied by another nerve, that is the trochlear nerve, which I will discuss now. And so now these two muscles, they are going to take over the function of the paralyzed muscles. So that at the end of the day, you have the eyeball being dropped down and out. Are you clear? So that is exactly what is going to. So the eyeball is going to be depressed down and out. So these are the problems that you're going to see or notice when the patient comes to you, with the paralysis of the oculomotor nerve. And so we have a break, and then we discuss the next cranial nerve.